What if the Earth spun twice as fast? Imagine if our Earth were to rotate at twice its current speed, making a day only 12 hours instead of the usual 24 hours. Could this lead to unimaginable, catastrophic changes? This change would not only affect time but also create profound impacts on the climate, geography, and even the very life forms on our planet. Let's explore an extraordinary yet risky scenario: Earth rotating twice as fast, and understand how it would affect everything around us. When Earth rotates at double its current speed, resulting in a 12-hour day instead of 24, many strange and unimaginable phenomena would occur. One of the most significant changes with widespread effects on all life on the planet is the increase in centrifugal force. Centrifugal force is the force created by Earth's rotation, pushing everything away from the center of the planet. As Earth spins faster, this speed will amplify the centrifugal force, making it stronger than ever before. This will have a particularly strong impact on the areas near the equator, where Earth's rotational speed is highest. The greater the centrifugal force, the more it will push objects, and even humans, away from the planet's center. As a result, near the equator, people would feel lighter. The gravitational pull would decrease due to the centrifugal force pushing upward, significantly reducing our weight. This would be a strange sensation, as every step and movement would feel different from what we experience now. On the other hand, at the poles, where the rotational speed of Earth is slowest, the centrifugal force would be weaker, and gravity would be stronger. This could make life forms in those regions feel heavier, potentially affecting their health and mobility. Not only humans but also natural phenomena would change. The oceans near the equator would be pushed farther out, altering sea levels and causing significant effects on the climate and ecosystem. If Earth were to spin faster, we would be confronted with a world where centrifugal force could change everything, from our physical sensations to the operation of ocean currents and even the distribution of ecosystems across the planet. This change wouldn't just be a scientific challenge, it would also present a complex puzzle regarding how humans and other life forms could adapt to the new environment. If Earth rotated twice as fast, the changes in the day-night cycle would trigger powerful climate fluctuations, creating unpredictable consequences for the environment and life on the planet. The increased rotation speed would alter not only centrifugal force but also the way the sun's rays impact and influence our landmasses, leading to stronger climate shifts than ever before. With a 12-hour day, Earth would experience a cycle twice as fast as it is now. This would make the sun shine more intensely on the Earth's surface in a shorter time, creating dramatic changes in temperature and weather. This effect would not only change how we experience light and temperature but also have direct consequences on weather phenomena. The alteration in Earth's rotation cycle would also cause wind systems to change. As Earth rotates faster, air movement would become more intense, winds would become stronger, and storms would become much more violent. Hurricanes, which can already cause significant damage, would escalate to much more extreme levels. This would lead to an increase in the frequency and intensity of tropical storms, large hurricanes, and other extreme weather events such as superstorms with extremely powerful winds, flooding potential, and significant damage. Just as wind patterns change with the seasons, faster rotation would cause wind currents to move more rapidly and potentially change direction suddenly. The increased intensity and frequency of storms would not only affect coastal areas but also have widespread consequences for inland regions. Areas that are currently calm and rarely affected by storms would now face an increased risk of intense storms. Sea levels would also rise more quickly, posing a danger to coastal cities and land areas. One of the biggest impacts of a faster Earth rotation would be the extreme fluctuations in temperature between day and night. With a shorter day-night cycle, temperatures would change rapidly and more intensely, creating dramatic swings in environmental conditions. During the day, temperatures would rise quickly because Earth would absorb energy from the sun in a shorter period, rapidly heating the air. However, at night, the cooling would also happen swiftly, creating a huge contrast between daytime and nighttime temperatures. These changes could result in abnormal cold spells or, conversely, excessive heat during the day. The sudden change in temperature will create ideal conditions for extreme weather phenomena such as heat waves, droughts, and heavy rainfall. Some areas may experience prolonged droughts, while others may face sudden heavy rains, leading to floods. Drought conditions would become more severe as water evaporates more quickly in tropical regions, reducing available water supplies, causing water shortages, and affecting agriculture. Agricultural areas might no longer have enough water for crops, impacting the global food supply. With the rapid change in the day-night cycle, seasons will also become shorter, making agricultural activities more challenging. Seasons will no longer last as they do now, but instead, they will move faster, potentially leading to instability in planting and harvesting. Areas that rely on seasons like spring and autumn will experience noticeable changes. The sudden shift between seasons could prevent organisms from adapting to the new environment, leading to ecosystem collapses. This situation will make it harder for animals to find food and suitable habitats. Species may face rapid changes in available resources, disrupting the food chain. Furthermore, humans will also face difficulties in maintaining a stable food supply, as the farming seasons become shorter, with droughts and floods potentially affecting crops. The change in Earth's rotation speed will not just affect one region but will have global implications. Extreme weather phenomena like heat waves, storms, droughts, and heavy rains will become more common and unpredictable. Regions that are currently considered climatically stable will face sudden changes in weather, potentially altering vegetation, ecosystems, and biological systems. Ecosystems will no longer be as stable as they are now, and humans will have to find ways to adapt to a much harsher environment. This is not just an issue of temperature or wind changes but a comprehensive environmental crisis, threatening life on this planet. These climate changes will make everything more difficult, forcing humanity to find creative solutions to survive in a world with increasingly harsh weather. When Earth rotates twice as fast, one of the significant changes we will face is the deformation of the planet itself. Earth, often imagined as a perfect sphere, actually has an oblate spheroid shape, flattened at the poles and bulging at the equator. This occurs due to the centrifugal force created by Earth's rotation. As Earth rotates faster, this phenomenon will intensify, leading to massive geological upheavals that we cannot imagine. Earth is not a perfect sphere but an ellipsoid, also known as an oblate spheroid, with a larger radius at the equator and a smaller radius at the poles. This is a result of Earth's rotation. The rotation creates centrifugal force, which pushes everything on Earth's surface away from the rotational axis. As a result, Earth bulges at the equator and compresses at the poles. This phenomenon has been known for a long time and is called equatorial bulge. With Earth's acceleration doubling, centrifugal force at the equator will increase dramatically, causing the equator to bulge even more. This will make Earth even more protruding in this region, possibly leading to changes in both the geological structure and other natural phenomena. As centrifugal force increases, equatorial regions will be compressed, and polar regions will expand. This process could trigger significant upheavals in the Earth's crust, causing powerful geological events. In this case, the pressures acting on Earth's layers will become stronger, increasing the likelihood of earthquakes, volcanic eruptions, and other geological activities. Regions near the equator, where centrifugal force is greatest, will experience the most significant bulging. As Earth rotates faster, the forces acting on the planet's crust will intensify in these areas, leading to geological disturbances. Fault lines and cracks in the Earth's crust will become more easily triggered, causing strong earthquakes and possibly leading to the formation of new volcanoes. As the equator expands, the polar regions will become compressed due to the increase in centrifugal force. This will impact the structure of Earth's layers and could create conditions suitable for phenomena such as tectonic plate movements, or even changes in the structure of the North and South poles. The polar regions, which are currently geologically stable, may face unprecedented pressures as centrifugal force at the equator increases, leading to changes in the landscape and geography. Although such phenomena may not occur immediately, over time, this change could cause tectonic plate shifts, creating new rifts and triggering geological faults in areas that have never experienced earthquakes before. This will increase volcanic activity and drastically alter the terrain of the polar regions. The acceleration in Earth's rotation will strain its geological plates. The stronger centrifugal force at the equator will exert pressure on the Earth's crust, heightening the likelihood of geological events. When tectonic plates are impacted strongly, faults will become easier to trigger, leading to earthquakes and more intense volcanic activity. These faults may not only affect areas near the equator but could also spread to other regions on the planet. From major faults to changes in volcanic activity, these geological disturbances will have a profound impact on humans and Earth's ecosystems. Earthquakes could devastate human settlements, causing significant damage to property and loss of life. Areas with active volcanoes will become more dangerous, and stronger eruptions could occur, producing ash clouds and toxic gases that affect the living environment. These geological disruptions will not only affect infrastructure and human life but also deeply impact ecosystems. Ecosystems that were once stable could be severely disrupted by these changes. Animals and plants may struggle to adapt to the new conditions due to consecutive earthquakes and volcanic eruptions, potentially leading to the decline or extinction of certain species. With changes in terrain and increased geological activity, some regions on Earth will face significant loss of natural resources, affecting the ability of both humans and other life forms to survive and develop. Earth will become a planet with a completely different landscape, where powerful natural forces continuously change and impact all forms of life. The acceleration of Earth's rotation will not only cause climate changes but also have a major impact on the planet's geological structure. The bulging at the equator and the compression at the poles could lead to dramatic geographical changes, causing tectonic shifts, earthquakes, and volcanic eruptions. These changes will not only affect humans but could profoundly impact ecosystems and the survival of all species on this planet. Earth will no longer be the familiar place we know but will become a planet full of upheaval and challenges. When Earth rotates twice as fast, one of the most noticeable changes we will experience is the alteration in the length of day and night. Instead of each day lasting 24 hours, the time between sunrise and sunset will be reduced to only 12 hours. Although this may seem like a simple change in time, it will have far-reaching effects, significantly impacting both Earth's ecosystems and biological cycles. Several important and challenging consequences will arise from this change. Before delving into the specific impacts, it's important to understand that the day-night cycle is not just a way of measuring time. It is a vital factor for the development and survival of life on Earth. From plants to animals, everything must follow this cycle to maintain life. Plants use sunlight during photosynthesis to produce the energy necessary for growth and development. Animals, especially those with circadian rhythms, must also synchronize with the day-night cycle to maintain important bodily functions such as eating, resting, and reproduction. With a day lasting only 12 hours instead of 24, plants will need to adjust their photosynthesis processes. Photosynthesis is the mechanism by which plants convert sunlight into chemical energy, providing nourishment and vitality. However, photosynthesis depends not only on the amount of light but also on the duration of exposure. The change in the length of the day will shorten the time plants can use sunlight, affecting their ability to synthesize nutrients and grow. If a day lasts only 12 hours, plants will face a shorter time for photosynthesis. This could lead to a decrease in the growth rate and yield of plants. As a result, crop productivity may decline, making it difficult to provide food for humans and other animal species. Plants may also need to alter their growth strategies to adapt to the shorter daylight period, such as changing the timing of flowering, fruiting, or altering their life cycle. For animals, especially those with circadian rhythms, the change in the day-night cycle will present major challenges. The circadian rhythm is the body's internal clock, which regulates physiological cycles, such as sleep-wake patterns, eating habits, and even reproduction. The circadian rhythms of animals have evolved over millions of years to synchronize with the day-night cycle, also known as the light-dark cycle. When a day lasts only 12 hours, the circadian rhythms of animals will be disrupted. Species that have adapted to feeding and hunting at night or during the day will need to adjust to the new day length. Some species may struggle to adjust their physiological cycles, leading to stress, reduced reproductive capacity, or even loss of survival ability. For example, wild animals, particularly nocturnal predators such as owls, bats, and lions, will have to change their habits to align with the shorter light-dark cycle. For animals kept in captivity, such as livestock and poultry, they will also need time to adjust their habits, including eating and resting patterns. Sudden changes in the circadian rhythm could lead to health disorders, reduced reproductive ability, and stunted growth. In fact, animals could even be affected psychologically and behaviorally, leading to problems like anxiety, behavioral disorders, and decreased communication. Humans are not exempt from facing this change. Although the human circadian rhythm is not as sensitive to the light-dark cycle as animals, adjusting daily routines will present significant challenges. In particular, shift workers who frequently work at night will need to completely change their sleep and wake schedules. Maintaining a good sleep routine and having enough rest will become much harder. Sleep deprivation, stress, and fatigue could lead to serious health problems, such as a weakened immune system, increased risk of cardiovascular disease, and psychological issues like depression and anxiety. Moreover, when animals are unable to adapt to the shorter day cycle, this will also affect the human food supply. Changes in animal behavior, from hunting to the development of aquatic species or livestock, could directly impact the availability of food for humans. The change in the length of day and night due to Earth's doubling rotation speed will not only disrupt human habits and routines but will also have profound effects on the entire ecosystem. Plants will need to adjust their photosynthesis cycle, while animals, especially those with circadian rhythms, will face changes in behavior and physiology. Humans will also need to learn to adapt to the new schedule, facing health issues and changes in daily life routines. In summary, Earth's faster rotation is not just a challenge for nature, but it will push humans and other living beings into uncharted territory. When Earth rotates twice as fast, not only the atmosphere and land masses will be affected, but the oceans, with their waves crashing against the shore and vast currents, will also witness significant changes. The increased rotation speed of the planet will have far-reaching effects on marine ecosystems, altering the structure of ocean currents and waves, while causing important disturbances in coastal environments and coastal areas. To fully understand this change, we need to examine the mechanism of how rapid rotation affects the oceans and the consequences it may bring. One of the key factors when Earth rotates faster is the increase in centrifugal force, which is generated by the planet's rotational motion and pushes objects away from the center of rotation. When Earth rotates at twice the speed, centrifugal force will become stronger, exerting greater effects on the oceans. This will increase the distribution of seawater, causing a shift of water toward the equator, where the centrifugal force is strongest. This shift not only changes the sea level height but also alters the slope and characteristics of ocean currents. The equatorial regions, where the centrifugal force is greatest, will witness a rise in sea levels, while the polar regions may experience a decrease in sea levels due to weaker centrifugal forces. This situation will increase instability in ocean currents, affecting coastal areas and potentially causing significant changes in marine environmental and ecological conditions. Ocean currents are large flows of seawater that move across the oceans, playing a crucial role in regulating the planet's temperature and distributing heat from the equator to the polar regions. When Earth rotates faster, changes in centrifugal force and the distribution of seawater will accelerate the speed and intensity of ocean currents. This could lead to changes in the direction and flow rate of key ocean currents such as the Gulf Stream. the North Pacific Current, and the Antarctic Current. A change in these ocean currents will have widespread consequences for the global climate. Ocean currents regulate ocean temperatures, affecting weather and climate patterns in coastal and land areas. When ocean currents change, it can alter global weather patterns, causing extreme climate phenomena, such as prolonged heat waves, large storms, and abnormal shifts in rainy and dry seasons. Regions that rely on ocean currents to maintain stable climates, such as coastal areas in Europe and North America, may face significant changes in ecological conditions and agriculture. As Earth rotates faster, not only will ocean currents be affected, but the frequency and intensity of ocean waves will also change. Ocean waves are generated by wind impacts, but the change in the planet's rotation speed will directly affect wind conditions, as well as the speed and direction of wave movements. Specifically, when Earth rotates faster, there will be changes in global wind patterns, especially near the equator. This could create higher and stronger ocean waves, while also increasing the frequency of storm surges. Coastal regions, which already face the destruction of waves and storms, will be even more threatened. High and strong ocean waves could cause severe coastal erosion, damage infrastructure, and place coastal communities at risk. Areas such as small islands or coastal regions will face flooding and loss of land, affecting the livelihoods of millions of people living there. Changes in ocean currents and waves will also have a direct impact on marine ecosystems. Marine species, from plankton to large fish and mammals, will have to adapt to the changing marine environment. Changes in ocean temperature, currents, and the distribution of species could disrupt the marine food chain. For example, fish species, which rely on ocean currents to find food and spawn, will be significantly affected if these currents change direction or intensity. Additionally, coral reef areas, which provide shelter and food sources for thousands of marine species, will also be impacted. Changes in sea temperature and current speed could cause coral reefs to die or fail to develop, thereby affecting species dependent on them. The marine ecosystem will face significant decline if there is no timely adaptation, potentially leading to a reduction in both the quantity and biodiversity of ocean life. The change in Earth's rotation, doubling its speed, will have far-reaching impacts not only on the atmosphere and land but also on the oceans and marine environment. From the increased speed of ocean currents to the strength of ocean waves, all these factors will cause significant disruptions in marine ecosystems, threatening the survival of many species and coastal communities. This change will not only affect the natural environment but may also have serious consequences for human life, especially for those living in coastal regions and dependent on the sea for their livelihood. When Earth rotates twice as fast, not only will there be major changes in the natural environment, but the artificial structures humans have built to support daily life will also face new, unprecedented challenges. Skyscrapers, bridges, dams, and other infrastructure built to withstand the forces of gravity and the surrounding environment will have to endure abnormal factors due to a sudden change in the planet's rotation speed. These changes will be especially noticeable in equatorial regions, where centrifugal force is strongest. When Earth rotates twice as fast, the centrifugal force, which pushes objects away from the planet's center, will become significantly stronger. This force will reduce the sensation of gravity in the equatorial regions and increase the impact on structures in these areas. Buildings, bridges, and large infrastructure projects will face a new factor that was never considered before: the increase in centrifugal force. The stronger the centrifugal force, the greater its potential impact on the structure of buildings, especially in the equatorial regions, where this force has the most significant influence. Skyscrapers, designed to withstand gravity and wind forces, will have to bear additional force from Earth's rotational movement. This could lead to instability in structures, especially those with fragile designs or lacking special support. These structures may encounter issues such as cracks, structural misalignment, or even collapse under extreme conditions. In the equatorial regions, where centrifugal force is strongest, structures will face a range of serious problems. Large buildings, Bridges, dams, and complex infrastructure designed to withstand the impact of gravity and other environmental factors may become unstable due to the increased centrifugal force. Changes in force distribution could weaken the durability of building materials and increase the risk of damage. For example, bridges connecting areas of large cities or critical infrastructure in the equatorial regions could be severely affected by changes in centrifugal force. Concrete and steel structures, though highly durable, could still be impacted by increased centrifugal force, leading to a decrease in strength over time. Large construction projects, especially bridges or hydroelectric dams, will face unprecedented challenges as centrifugal force increasingly affects their structures. In particular, structures located in coastal areas, regions adjacent to the sea, may encounter even more serious issues. The centrifugal force will alter the tilt of structures and may cause displacement in the underlying soil layers. This is especially dangerous for structures near coastlines, where they are already subjected to the forces of water, ocean waves, and sea level changes. Changes in force distribution could lead to soil displacement, causing structures to crack or even collapse. To address these changes, engineers and builders will need to redesign existing and new structures based on the new centrifugal forces. This will require the development and application of new technologies and building materials capable of withstanding the stronger impact of centrifugal changes. For example, lightweight yet extremely durable steel structures could be used to construct skyscrapers, minimizing the risk of damage from centrifugal forces. Bridges and dams will also need to be redesigned with stronger support systems to withstand these new forces. Additionally, the use of elastic building materials, capable of resisting sudden changes in force, will become a critical requirement in design and construction. Structures in equatorial regions, where centrifugal force is strongest, will need additional layers of materials to mitigate the direct impact on the primary structure. Furthermore, buildings will need to be reinforced with vibration-resistant systems to reduce the movement of structures under the influence of increased centrifugal forces. With the drastic change in Earth's rotation speed, artificial structures, particularly large ones in equatorial regions, will face a range of new challenges. The increased centrifugal force may heighten the risk of damage and threaten the stability of buildings. From skyscrapers to complex infrastructure, these issues will require innovative efforts in design, construction, and maintenance to ensure safety and stability in a world where Earth's rotation speed has changed. When Earth rotates twice as fast, one of the most noticeable and far-reaching changes will be the alteration in gravitational force. Gravity, the force that Earth exerts on all objects to keep them on the surface, will not change so drastically that humans will feel a significant difference. But it will still affect many important factors in Earth's ecosystem and atmosphere. One of the notable consequences of Earth rotating faster is that centrifugal force, the force pushing objects away from the planet's center, will increase. Particularly in the equatorial regions, where Earth's rotation speed is fastest. This centrifugal force will counteract gravity, slightly reducing Earth's gravitational pull in these areas. Therefore, at the equator, gravity will decrease slightly. Although the decrease in gravitational force is very small and not noticeable enough for us to directly perceive, since the change is only around 0.5% in certain situations. This change can affect natural processes such as the movement of water, the atmosphere, and even the formation of ocean currents. On the other hand, in polar regions, where Earth's rotation is slower and the centrifugal force weaker, gravity will increase relatively. However, this change is still not strong enough for us to immediately notice. The reason for this is that gravity is primarily due to the mass of Earth and does not change drastically. Nevertheless, the increased gravity at the poles will affect factors related to the distribution of water and the atmosphere. One of the most significant impacts of the change in gravitational force is its effect on atmospheric circulation. Gravity plays a crucial role in keeping Earth's atmosphere close to the surface, creating atmospheric layers with different densities and properties. When gravity changes across different regions of the planet, These layers of air will be redistributed. At the equator, where gravity slightly decreases, the air will become lighter, leading to changes in atmospheric currents. The atmosphere will tend to expand, affecting large airflows such as monsoons and other atmospheric circulations. This change could alter wind movement, making weather systems more unpredictable and potentially causing greater fluctuations in weather phenomena such as storms and rainfall. In polar regions, where gravity increases, the air will become heavier, which could slow down air currents and make them more stable. The polar regions might witness changes in atmospheric flows, leading to changes in local climate conditions, such as variations in cold winds or the formation of auroras. Besides the atmosphere, another important natural system affected by changes in gravity is the oceans. Gravity plays a crucial role in maintaining the stability of ocean currents, huge flows of seawater that move throughout the oceans and influence global climate. When Earth rotates twice as fast, ocean currents will be affected by changes in gravity. Especially at the equator, the change in gravity could alter ocean currents, changing their direction and potentially impacting the surrounding climate regions. Ocean currents like the Gulf Stream, which helps regulate the climate in northern Europe, may need to adjust their speed and direction, leading to unusual climate changes in these areas. This change could also affect phenomena like El Niño and La Niña, two important climate events that influence global weather. These phenomena could occur with greater frequency and intensity, changing the characteristics of marine regions and affecting economies that depend on seafood and maritime transport. Because gravity influences the movement of water and the atmosphere, this change will impact marine ecosystems, particularly in coastal areas and oceans. Marine life such as fish, shrimp, shellfish, and underwater plants will need to adapt to changes in their habitats. Changes in water temperature, salinity, and the distribution of currents will have a significant impact on the ocean's food chains, altering marine ecosystems. Marine species, which have already been affected by climate change and water temperature, will now face a rapidly changing marine world. These species may need to migrate to other areas or even face the risk of extinction if they cannot adapt to the new conditions. Although this change in gravitational force is not large enough for us to perceive directly, its impact on the atmosphere, ocean currents, and marine ecosystems will be crucial factors in shaping a new world. Even a small change in gravity can cause Earth's natural systems to change in ways we have never imagined. This reminds us of the intricacy and deep connection between all the elements in the planet's ecosystem, and the need to fully understand the impacts of this change on our future. So, together we've explored the far-reaching impacts of Earth rotating twice as fast. These changes, although scientifically intriguing and hard to imagine, clearly reflect the complexity and interconnectedness of the elements within our planet's ecosystem. From the shift in gravitational force to disturbances in the atmosphere, oceans, and even human-made structures, it all shows that we live in a highly complex natural system where even the smallest change can have significant consequences. So, what do you think about these impacts? Could these changes lead to major challenges for humanity? Or will we find ways to adapt to a constantly changing world? Feel free to share your thoughts in the comments below this video. If you found this content interesting and valuable, don't forget to like and share it with your friends and family to explore more fascinating knowledge about our planet and the vast universe around us.